Okay, I am going to find the sine, cosine, tangent of 2 theta using the information given here, that the angle lies in the second quadrant. The sine is 8/15. I'm going to use these double angle formulas. Since the sine of theta is 8/15, I know this is 8 opposite, and I know this is 15. Using the Pythagorean theorem, 15 squared minus 8 squared square root, I can find that this side is radical 161, and it has to be negative because this is the negative x direction. So I can also find cosine is negative radical 161/15, and I can find tangent, opposite over adjacent, 8 over negative radical 161. I need both of those to plug into these formulas. If I start off with sine, I know that's 2 times sine theta, which is 8/15, times cosine theta, negative radical 161/225. Oops, sorry, over 15. I'm getting ahead of myself here. I'm doing the multiplication. So this will be negative 16 radical 161/225. Okay, for cosine of 2 theta, I can use any of these formulas. I think I'm going to use the one with the sine squared just because this is a little bit simpler, in my opinion, to work with. So this will be 1 minus 2, 8/15 squared. 15 squared is 225. And then if I do 2 times 64, I get 128 for that numerator. To get a common denominator, I'm going to change this 1 into 225/225. And I get 97/225 for cosine 2 theta. Finally, for tangent 2 theta, I'm going to do 2 times negative 8 over radical 161, 1 minus negative 8 over radical 161 squared. So this will be negative 16 over radical 161. This will be 64 over 161. And again, with the concept of a common denominator, I'm going to change this into 161 over 161. So this is going to be negative 16 over radical 161 over 97 over 161. If I change this into multiplication and flip this one, I get negative 2576 over 97 radical 161 for my answer. Now you could rationalize this multiplying by square root of 161 over 161 if your instructor requires that. Otherwise, there they are.